Henry.
I mean, it's up to you however you want to run the session.
Okay, so I'll introduce
Want to
you and
grab
then
slides up or
you
not?
share that. So I guess we are starting this session. We are on the last round of sessions for Vitro ICSI. And in this session, we have articles from the Journal First, new ideas in emerging results, and also from the technical track. We're going to start with Ayushi Rastogi, who will be presenting, including everyone, everywhere, understanding opportunities and challenges of geographic gender inclusion in open source software. And this is a Journal First article. Please go ahead.
Great. Can you see the screen?
Yep.
Hi, my name is Ayushi Rastogi. I'm an assistant professor in software engineering at the University of Groningen. And this is a joint work in collaboration with Artha and David from Singapore Management University, Dinesh from Microsoft Research, Rahul from IIIT Delhi, and Nachi from Meta Platforms. There are studies in software engineering that have shown, despite no significant differences in the working pattern of men and women, there are differences in how the contributions are evaluated. For instance, the contributions of women are more likely to be accepted when gender identity is not known. Likewise, there is another study that shows that the geographical location of developers, some developers are more or less likely to have their contributions accepted. So taking these explorations a step further, in this study, we are trying to understand the opportunities and challenges of geographic gender inclusion in open source software. Our vision is that through this and subsequent research, we can achieve our grand vision of including everyone, everywhere. So our study had two parts. First, we used archival data on GitHub to characterize the geographic gender diversity as is seen in the open source projects hosted on GitHub. We also conducted a survey to identify factors that can influence the participation of gender diverse geographic participants. So our analysis showed that the gender diversity is low worldwide. To give you a sense of scale, an ideal Blau index would be 0.5, which would have meant 50% men, 50% women. And while not statistically significantly different, we see that gender diversity is higher in Americas and Asia in comparison to Africa and Europe. But the good news is that there has been a small improvement in the gender diversity in the last 5 years, with Northern Africa leading the list. I believe that this can be attributed to all the initiatives that have been taken in the field of computing, the industry that is coming up to promote gender diversity. Our next analysis was to see if there is any correlation between gender diversity and geographic diversity. To our surprise, we saw that there is a negative correlation between gender and geographic diversity, which mean, if it holds true, that increasing or trying to increase gender diversity could negatively influence geographic diversity and vice versa. But this is something that future research should investigate. And then we moved on to survey in which we tried to gather the perceptions of people of men and women balanced across different geographic regions. So you can think of it that we tried to contact at most 50 developers per group. In the end, we contacted 1,500 developers, out of which we got 118 valid responses. So what you see next are just some of the key insights of our analysis. One of the key difference that we saw was that women developers emphasize social aspect. So for them, working with a friend or colleague is more important than their men counterparts. Likewise, shared identity is more important for women than for men. And regionally, when we look for these differences, shared identity was more important for the developers from Americas, but that was not quite the case for developers from Africa. We also looked out for the incentive model and if it has any impact. We saw that monetary incentive was more important for women, and likewise, getting paid was a bigger motivation for developers from Africa than it was for the developers from US or Europe. But here I would also like to emphasize that the data suggests that the developers from US and Europe are more likely to be paid for their jobs. So this and several other insights that are presented in our paper makes us think, how can we build communities inclusive? And one of the insight or and recommendation that we have for our work is that if we can highlight contributions of marginalized not just in GitHub, but maybe also outside. And so just to summarize the key takeaways of our work, so we found that gender issues are quite similar worldwide, although the solutions that can promote gender and geographic diversity are different. So if you're interested in reading more about this work, please refer to the QR code on the top right. And if you want or are interested in replicating our work, see the QR code on the bottom. And with this, thank you. Thanks for listening.
Thank you. Yugi from the University of Groningen, I forgot to tell. And this is Tim Menzies, the next from the University of
North Carolina.
North Carolina.
North Carolina State. So I want to talk about assessing practitioners' beliefs in software engineering. And this talk is very different to the one before. The one before and several of the ones that follow talk about assessing beliefs with respect to community surveys. This one is about assessing beliefs about technical matters according to historical data. Why check our beliefs about software engineering? Well, if you go to the Wikipedia page on human cognitive biases, you will find 153 ways that people typically get things wrong. Repeated experiments show that humans get things wrong all the time. So if we ask about what do we really think about how programmer experience affects productivity, or how programming languages affect defects, or how programming sizes affects defects or whatever, we find a variety of beliefs, but we don't find much evidence that actually checks those beliefs. Now, recently, thanks to my distinguished colleague, William Nichols from the Software Engineering Institute at Carnegie Mellon, we came across the most beautiful data set. This is thousands of developers, all have done the same 10 tasks in 10 different countries, 10 different domains, many different languages, and from the years 2006, 2014. And all these people were practicing the personal software process, which, as many of you know, means you're recording in detail what you think and how long things take. This is a fantastic data source where we can go and check certain background beliefs about software engineering. So when we check them, we find, like, is it true that language 1 gives you certain bugs, and if you switch to language 2, you don't get those bugs? Well, that's not really supported. And here's one that I used to make a lot of money out of in the 1990s. That's how old I am. Object-oriented code has got less errors. That is not true. Does doing early life cycle work obviate the need for later work? And that's not necessary. Yes, there's a very weak effect that early thinking removes later rework, and it's a good. And that effect's very weak, and that's good, because if that was very strong, that would put a crimp in agile and exploratory methods. And the idea that you're experts after thousands of hours, the Martin Gladwell hypothesis, we just didn't find support for that. If we wanted to check the validity of our results, we couldn't check these hypotheses directly in this data without coming up with partial indicators that map from this data to these hypotheses. So if you want to critique our work, you can critique the indicators, but we spent time on that. But the main message we want to say here is that many of our beliefs don't hold. If you're in some environment where someone is authoritatively putting down someone else, that put down could be very inappropriate because the evidence for our beliefs is very weak. We really need to look more. And these beliefs are important. They're used for how we design teams and software, how we teach software engineering. And we really need to check this stuff more. Thanks for your time. And I'll be around for questions at the end of the other speakers.
Thank you, Tim. And next we have Matthew Fraser from the University of Delaware, who will be presenting investigating user perceptions of conversational agents for software-related exploratory web search. And this is a new ideas and emerging results article.
Yes, thank you. So I'm at Fraser. I'm talking about our NEAR paper. So software developers use web search often in the day-to-day workflow. Web search can be largely categorized into two different types of search. Lookup tasks, which are basic fact retrieval, question answering, navigational types of searches, or exploratory search, which involves learning and investigating different types of ideas. We find that software developers are finding things relatively easily. However, for exploratory tasks, developers are often unsuccessful at quickly finding useful information for their exploratory needs. This software engineers utilizing an open domain conversational search agent for performing exploratory search. When we say open domain here, the chatbot's backend is actually a Google search engine, as opposed to the chatbot being backed by a database. However, there's other similar research to ours. There's other supporting Wizard of Oz studies. However, these other studies perform lookup types of tasks as opposed to exploratory, and a variety of other chatbots in software engineering. However, all these other chatbots are largely backed by databases. So to determine the efficacy of an ODCSA for software engineering exploratory search, we pose the following two questions. One, can ODCSAs help software engineers be effective at performing exploratory search? And two, how far does the current generation of ODCSAs go in helping software developers with their exploratory search? To answer these questions, we set up a Wizard of Oz study. We had a commercial ODCSA, which is BlenderBot 2. Wizards curated canned responses and internet search available. We recruited 18 diverse college programmers. We held 1-hour sessions where there were 2 tasks, 1 task per 30 minutes of the same exploratory search intent. Answer a task per each chatbot. And then participants answered a post-study survey about their experience with the agent. The post-study survey largely had 3 parts: Likert scale type questions, some open-ended questions, and also demographic data. The Likert scale questions were specifically curated towards interaction and usefulness type questions. We wanted to see how human-like the chatbot behaved, as well as how useful it was at providing internet search data. For our results, to answer research question 1, we looked at the Likert scale data for the Wizard-backed chatbot. We can see that largely, nearly all people agreed the interaction with the Wizard was very helpful and interactive. Nearly all people agreed that the agent, they can understand the agent and it can understand them. Little people believed that it behaved awkwardly or asked too many questions. In terms of usefulness, nearly all people agreed that the agent also provided useful information. Nearly all people thought that the agent, they felt like the agent helped them, and 14 out of 18 would suggest using the Wizard in the future. So we can summarize by saying that users of an ODCSA backed by a Wizard find it helpful for gaining useful information from software engineering tasks or exploratory research. In terms of research question 2, we compared and contrast the state of the art with our Wizard. And in terms of interaction, we largely see that the state of the art was actually very interactive. 15 out of 18 people agreed that they can understand the agent. Little that behaved awkwardly or asked too many questions. However, on the contrary, 8 out of 18 thought that the agent can understand them, the state of the art can understand them. And in terms of usefulness, we see a drastic difference between the state of the art and our Wizard. Only 6 out of 18 people thought that the state of the art provided useful information. 5 thought the agent helped them, and only 4 would recommend using the state of the art in the future. So we can see that there's a large gap between the current generation of ODCSAs and what participants would want in such a conversational agent for software engineering exploratory research. In terms of future work, We want to collect more data and run more sessions. We also have a large portion of unanalyzed data that we're going to analyze in a potential journal paper. We have our search queries that were from the state-of-the-arts queries. We have the task outputs and also our conversation data context. Summary of our contributions, we provide a corpus of 18 Wizard of Oz exploratory research dialogues for software engineers, as well as our post-study results, including our programmers' comments and the performance test outputs. And we'd like to acknowledge the NSF for funding our research and also the co-authors of the paper. Thank you. That concludes my talk.
Matthew. And the next two articles are from the technical track. The first one has been nominated for a Distinguished Award. This is the article from Rony Santos, who's representing a grounded theory of coordination in remote first and hybrid software teams. Ron is from the Dalhousie University.
Thank you, Kev. Hi, everyone. So as our title says, we investigated the effects of the pandemic on the work of software professionals. To run this research, we spent 1 year and 6 months within a software company where we collected data from the beginning of the pandemic when people moved from home till they start to grow accustomed to flexibility, and also when they start to talk to the company about the possibility of keep working from home or working in a hybrid arrangement. So we collected data starting with field notes. We start with our observations and also collecting data from emails and posts in the company's channels. As you can see, some of our data was our main data analysis process was a qualitative, so we had to convert some of the information that we were getting from the participants into text, because some of them were emoticons or videos or even memes. We used grounded theory in this study. So pretty much we were interested in everything that could represent some kind of valid data for our study. After field notes and collecting information from channels and emails, we start to interview professionals in the company. And we also start to look closely into two projects that were working into different technologies and running completely from home during this scenario. We interviewed those professionals, and these interviews were used to create categories because we had codes from fields and from the initial interviews. So as we keep interviewing people, we start to create categories and linking these categories together to the point that we start to see our main category to emerge. But the real deal in here is that when we start to analyze data from retrospectives, and this is when the main category emerged, which is software team coordination. This is how a theory looks like. So as far as we understood, we have some protective factors that can shield software team coordination of when professionals are working from home or using some kind of hybrid arrangement. So they are group cohesion and effective communication. This is supportive for team coordination, but we also have some factors that can disrupt this coordination. They are distrust, parenting, which can create some kind of distractions and stuff, and also what we call communication bricolage, which happen when some individuals on the team, they create clusters to work together, and the information that they share about the project is start to keep only in this bubble and do not flow to the rest of the participants, to the rest of the team members. So these are risky factors. We also understood that if the team coordination is not controlled or well managed, so some problems are triggered. They start with misunderstandings in the requirements, increased requests for help among team members, also the dissatisfaction of the team. And this dissatisfaction is not related to the coordination itself, but the perception that if they see the coordination disrupting, the professionals might think that they will have to go back working to the office as it was in the before the pandemic. And this is right now is not the reality that software professionals want. So this not being satisfied with the project can come from that. We also have a problem with ill-defined tasks, which happens when professionals can see the tasks being completed. Like they cannot see the tasks as a complete piece of work with beginning, middle, and end. If these problems are not well managed, so we have the need for method engineering, constant changing on the practices and the processes applied on the team, and we also have some indicators of reduction of the software project success. So our implications is that as hybrid teams and remote first teams tend to increase now after the pandemic is gone, so we need any kind of strategy that can support software projects to keep on going. And our theory is one step forward this. We suggest the improvement of communication to cope with remote and hybrid team in a way that more asynchronous information can be available to the team. We also have the need for creative strategy to support parents, especially because parenting can be one of the risk factors in this scenario. We have the need to be always prepared for method engineering or re-engineering, like not being afraid of changing your practices if it's necessary and being prepared for it. And we also have the need to increase team engagement and support to cohesion. In fact, regarding this, we have a paper that it's accepted to Chase. We're going to present next week. It's about practices to improve teamwork in software development during the pandemic. So I invite everyone to read the paper or to be on a presentation if you can. And well, this is our conclusions. Effective coordination of remote first and hybrid teams is a very important aspect of software development right now, especially regarding the success of software projects. And our theory is there to help managers, to help software practitioners to deal with these problems. And as for future research, we intend to keep working on these aspects because one thing that we saw is that some of the reality right now that we can expect is that some practices might backslide to pre-agile era, like the more, I don't know how to say, but the need for practices that were used 20 years ago in software industry, and they might not be effective in our reality right now. And we also have to be prepared for use what we learned from this pandemic to be prepared for future crises. This is also in our radar right now as future research. So this is our paper. If you have any questions, there is a lot of ways to find us. We will be happy to discuss any of these matters with you. Thank you very much.
Thank you, Ronnie. And then we reached the last presentation. It's social science theories and software engineering research. It's going to be presented by Tobias Lorry from the University of Innsbruck, also from the technical session.
Yeah, perfect. Thank you for the introduction. You can see my screen well?
Yes.
Perfect. Thank you. So welcome to the second presentation for the paper Social Science Theories in Software Engineering Research. Authors of this paper are Paul Ralph from Dalhousie University, Michael Felderer from the University of Innsbruck in Austria, and my name is Tobias Lorry, also from the University of Innsbruck. As we only have 5 minutes, let's jump right into the topic. Software engineering is a fairly young field with constantly emerging phenomena, and we find ourselves more often concerned with topics that are not purely technical, but rather related to human factors. For instance, the motivation of software developers, work-life balance of professionals, economic factors in projects, as well as strategies for learning come to mind. And at the same time, there's an increasing interest in theory use. There have been, for instance, a number of theory workshops and special sections in journals on theory in software engineering. And that's no surprise because there are many benefits of incorporating theory into research. We are able to mature the discipline, to organize and preserve knowledge, explain and predict phenomena, and improve the quality of our research while reducing the need for trial and error. And given the increasing importance of both theory as well as social factors, we wanted to investigate the use of social science theories by performing a critical review of existing literature. And to do so, we examined articles from 5 software engineering journals over a course of 13 years by searching for occurrences of theories from a social science discipline, and discovered theories were then inspected and classified according to several characteristics, including the discipline of origin, from which discipline the theories come from, theory scope, and so on. And we also sent out a questionnaire to authors who applied theories in those primary studies to ask them about their experience and challenges with applying social theories. So now let's take a look at notable results of our critical review. We retrieved just short of 6,000 articles from software engineering journals. Excluding non-research articles, we were left with over 5,500 articles to scan for theories. And after searching each article, we were able to find and include 102 primary studies which used at least one social science theory. We found a total of 87 unique theories from social science disciplines which were used in these primary studies, which corresponds to less than 2% of articles using social science theories. It's interesting to note that about 1/3 of the theories we discovered was used in multiple articles, while 2/3 were used in exactly one article. And by far the most used theory is TAM, the technology acceptance model, which is used in 13 papers, followed by a dual coding theory and a diffusion of innovations theory. What is really interesting is that the authors used theories mainly to inform the study design. So we found a lot of authors using theories to formulate hypotheses, to pose research questions, and also to design surveys. The majority of theories came from psychology and management, which also includes information systems, as well as organizational studies, where we found quite a few theories from. And this makes sense as software engineering research is often concerned with the psychological and management topics. Other disciplines we identified were economics, education, communication studies, sociology, philosophy, and also linguistics. We also mapped the articles using one or more theories to knowledge areas and found that a lot of them are from the area of professional practice, which also makes sense given that social theories are likely most helpful in this area related to human aspects. Now I would also like to mention responses of authors using social science theories. We asked them about benefits as well as challenges they encountered when applying theories from a social science. One benefit the authors mentioned quite often was that there is actually no need to reinvent the wheel. Other disciplines often have concepts to explain those phenomena we are looking at, especially concerning human factors. Theories are able to provide the theoretical foundation and provide guidance for research. And they also provide us with an interdisciplinary perspective by connecting technical with human aspects. And while the overall attitude towards theories was very positive, we received a number of challenges. In a discipline like software engineering, which is often guided by practice, theories sometimes seem a bit too abstract to be useful and sometimes do not fit the emerging questions of today. We also received many responses indicating that it takes a lot of time to fully understand those theories, especially from social sciences, and that there is quite a bit of uncertainty attached to using theories, that everybody does it differently, and that space for interpretation and failure is needed for authors to apply theory and to get motivated to using theories. That concludes the presentation, and I would like to thank you for your interest in our topic.
Thank you, Tobias. Thank you, everyone. So I probably forgot to present myself. I'm Kiev Gama from the Federal University of Pernambuco in Brazil. So this is where Ronnie did his PhD. And I would like to ask the audience to post messages on the chat so we can start a discussion. But before that, in the meantime, I would like to connect this session because I don't know if everyone was well virtually attending to the keynote this morning from Lionel Bion. And he mentioned three communities under his perspective in the software engineering community as a whole. So he was mentioning formal methods and guarantees, a focus of one of the communities. The other one will be engineering automated solutions, and there is another community focused on human and social studies. I guess this third one is where these works are concentrated, since we are in the human aspects of software engineering session. And one of the things that he said is that he sees a disconnect between these three communities. So how do you see your individual works that have been presented here approaching or potential to approach these other communities? I know Tim has some work on this community on engineering automated solutions. He has some connection with that. But I would like to understand those three communities. That will be formal methods, and the second one, automated engineering solutions, and the third one will be the social aspects of the human and social studies in software engineering. So, how do you see this disconnect and the potentials to approach these other communities?
If you look at cognitive theory, if you look at the list of theories in the last paper, Paul, Ralph, and Michael, and you can see on page, there's table 2 of that one, has got a lot of cognitive stuff in it. One of the reasons originally we studied AI was to understand the humans. A lot of education in computer science education people accept as base their assumption that there's a symbolic process of long-term and short-term memory, and there's a symbolic reasoning about that. A lot of my own thinking has been about that as well. How do we extract features so that you have only a small number of things put in short-term memory? I can see a strong connection. I don't see a dichotomy between the three you offer. I can see a strong connection between cognitive theories, participant observation, exploration, formal methods.
Okay. Well, Tobias, since you've been presenting work on social theories from the social sciences, how do you see this disconnect, and how to approach this these other two communities, if possible?
Well, I would say that, speaking from the perspective of our paper, we actually want to integrate the human aspects, the social science aspects, into the other research areas. So I don't want to emphasize the disconnect, because software engineering is really all of those three communities combined. I mean, we cannot exclude one of those three communities and just brush it off as okay, that's just not part of our research. So I would say that being open to other communities, to other research areas, to other research focuses is really important, and to really consider those other communities. If you consider yourself part of one of those communities, consider those two other communities in your research. Don't brush it off.
Thanks. Any other opinions? That's well.
I have two other thoughts, but I want to
yeah,
hold to other people
go ahead.
talk.
Okay.
Well, honestly speaking, I don't think we should be talking so much about the disconnect per se, because software engineering as a field has evolved from many of the other things that we are talking about. So we have borrowed elements from there, so it's natural that we will take elements from there to understand our software better. I think the disconnect that might have been referred here could just be coming from the fact that we all are very comfortable in, doing work within our little bubble and not looking outside. But I think I don't think there is a source for solving this problem. This is something that each and every individual will have to explore on their own.
Cool. Any thoughts from the other ones? Ronnie, Matthew?
I think we got another hands up here from Paul.
Yeah,
Can
go
I
ahead.
can I offer some thought on this?
Yeah.
So it seems to me that not everybody, but many people in the formal methods and the engineering side have, don't pay much attention to social theory, right? And both the paper with Ronnie and the paper with Tobias are about the kind of theories that psychologists and sociologists recognize as theories and what they're for and what we can do with them. And it's kind of like wearing glasses that make the world black and white. And so when a person who's enmeshed in the culture and the thinking of the formal methods community or the more engineering side, like for example, goes and watches somebody interviewing a prospective user of a software system, what they see is the eliciting of requirements, right? The person says what they want and you write it down. But when you're a social scientist and you go watch that same interaction, what you see is the co-construction of meaning between two people with different perspectives who are coming together some action into the future. And that more nuanced, colored view of what's going on helps us immeasurably to do formal methods and engineering better. So the kind of the point of the social theories paper is for software engineering research to be more effective, it has to pay more attention to the ideas that come from social sciences, because those ideas allow us to see the world in greater color and nuance and shades. And that way of seeing the world is necessary for us to be successful.
Yeah, agreed. And we see that black and white thinking not only in software engineering, but in politics everywhere today. So it's a timely topic.
Well, I'm sure you're right, but I noticed that your paper in a software engineering journal got a distinguished paper award. So I'm sure you're right that there are communities that would have rejected your work out of hand, but in this particular case, so I've got more stories of successful union than stories of isolation and separation. If you look at all the people doing software analytics, more and more they're engaged in grounded theory, user construction. If you look at some discussions about how you predict for software quality, there are product metrics that describe in detail the system. And then there are process metrics about who does what and whether you've used this business thing. And just it turns out that these process metrics do much better. It turns out software is written by people. And the more we know about the people writing the software, the better we have predicted for bugs. Another thing is, and just to offer a concrete example of where these ideas match, Paul was talking about groups coming together and creating a joint opinion. When I hear that sentence, I see a search space with lots of local maxima, and that there's multiple ways to construct a theory. And if we listen very hard to the agents walking that space, we could learn the local biases that make things interesting, which help us predict how they might do better in the future. So I've got a very strong symbolic cognitive view of things that combines things. So I can find more examples in our current SE world of listening to multiple sources than I can of separate silos where people say, screw you to to other groups. I think so. This is a very exciting time.
Well, thanks for your interventions. Well, personally, I think these human aspects are very orthogonal, as it was mentioned. Software is made by people. Well, still made by people, right? So, and one thing that was Rodney's article was very timely in the aspect that is well, documenting a lot of things that happened during the pandemic. So although the context was very strict for one company only, but a lot of the results, I think, that it resonates with many people. Well, I have a 2-year-old now, but well, it was much younger when the pandemic started, and so it was much very complicated. But one thing that I was trying to find in the article, just well, maybe a suggestion or something for the future, is the concept of awareness. You're talking about coordination of tasks. The concept of awareness from the CSW community. I don't know if you stumbled upon this concept. Are you familiar with that? So being aware of each other's tasks in a team. So it's a way to coordinate.
Well, I kind of touched on that thing when I was talking about distrust, because but in this case, awareness was so as something, I might say something bad, because you have awareness. You need a constant validation of what you are doing, because you're suppressing about yourself and other people's work. So we kind of touch in that during distrust, but we didn't didn't dive into it very much when we are exploring the categories. And I agree with you that we were in one specific context, but the company has several international clients. As you know, it's Caesar. So yeah, we were working with people that were working with Motorola, Samsung, and other clients. So they were facing the pandemic both inside from the context of the company in Brazil, and also from outside, because they were working with these clients. So yeah.
Okay, thanks. So Matthew, there was one question that you entered here. Maybe you want to bring more details. It's from Diksha Arya. She said she was wondering if you had any insight on whether in what context participants specifically preferred conversational agents over normal searching, especially in the case of usefulness. So, what would you like to complement that?
Yeah, I think that's more or less talking towards the motivation. Yeah, we did see there were a few papers motivating this, that often software engineers specifically for exploratory search are reformulating queries often. And then what they were formulating the queries into our conversation starting questions. So which was sort of the motivation behind, if there was a chatbot available to assist in exploratory search, would that aid software engineers in finding useful information. So yeah, there's a few papers, and I can link those papers if you're interested in the reformulation of queries question.
Cool. So
one thing I get sometimes is that there's a sort of bogus claim that the automated methods scale better than the sort of human-intensive interview methods. Ayusha, I'm having paper blur right now, but was it your paper that said there's a way to do grounded theory incrementally? You don't have to buy into the whole thing. You can do, no, okay, I got that wrong. But you know, there's well, okay. What do our panelists think about scalability and qualitative methods? The ability to make conclusions across, you know, hundreds to thousands of projects.
Well, it's definitely time intensive, especially if we are intending to do something that requires understanding. And I think, but I would believe that if somebody is trying to do qualitative analysis at such a scale, maybe in some form technology can be helpful. And that brings me to the next question. that why is it important to study thousands of projects, for instance, when we can study, let's say, representative 10 projects per category? And I think, Tim, I'm putting this question back to you because it's not always about the numbers. So should we really care about the quantity when we are talking about qualitative analysis?
Well, we have exciting results on that one. We have an MSR paper where we went to 700 projects in the defect prediction. And then we went to 1,600 projects in defect estimation. And then we did clustering and said, can we find the representative projects you speak of? And we could find in defect prediction 1 or 2 representatives, suggesting that much of that work is unnecessarily complicated, a simple structure. And for effort estimation, we could find 12 representative projects. So that's actually the model I'd suggest. You've got methods that work at scale that come up with representative examples. And what I find really powerful are the contrast sets. That if you've got two clusters of things, the delta between them is usually a small set to offer people. And then so it's a cycle where you can move between these two processes, and then the qualitative methods propose theories that come back and be checked at scale, and then results from that come back. And we tried proposing this. We took a Jim Hirschlab theory, and at ICPC 2 years ago we proposed this. We're very excited about it, and no one seemed to care. But I'm just agreeing with you, strongly, that there's ways to put these things together where humans can be focused on the most representative examples, and you do mass data collection and theory pruning as a second cycle around people. So marrying the methods.
And further adding, I think we as a community perhaps are not very receptive to this idea. And we always, now that we have so many projects and data, we always think about scale. Like, if you have to build a theory, study 1,000 projects. And I would sometimes want to challenge, why not start with theory from one project and then see if somebody can come up with a counterexample, maybe another kind of representative project, and propose a counter argument. And that's how the theories can evolve, more organically, instead of expecting in the first place that a person should have analyzed 1,000 projects and come up with the awesome theory to begin with. And I think we are really making it difficult on us as researchers to do research by putting so much expectations of having one correct solution in the first go. I don't know what everybody else thinks about it.
While I want to agree with you in everything you say, I have to disagree with you with that one. One thing we found with the clustering analysis is that we generally put things in groups of 20. And the theory that predicted most for the others went up one level to the next level of the cluster. And then there was another fight. And the theory that predicted best, okay. Thing is, at each level, we did knock out 19 out of 20 of the theories. So at probability 19 out of 20, if you went into, you might be dealing with quirky outliers. So I strongly recommend a clustering over a very large space to come up with the representative examples. And then I strongly recommend your methods based on those representatives. But I think if you just start, that's my worry with Ronnie's stuff. It's great stuff, but it's one project. Was there a pre-study that looked at 1,000 candidate project the one who came in on, or was it an opportunist thing where they had the contacts and they could go into one project and get that stuff? And I'm going to guess it's the latter, by the way, Ronnie.
If I may, it was 50 projects because the company had like 50 projects running at the same time. So
right, and 50 IBM projects.
Which means that
50
each
to 50
project is a
Microsoft
different
projects.
world. Yeah, I dive into two because I was working with two, observing them every day, but I had data coming for other 50s. And one thing that I might add in here is, well, I don't know if I get it, but for instance, you have other papers about the work during the pandemic, and everybody saying great, good things about productivity, but how software engineers are viewing the productivity. But I saw differently. Actually, we had this discussion last night because some of the people, I mean, and it wasn't a very representative group of professionals, but some of them were being overloaded with work because they wanted to. They wanted to show to the company that they were working too much, which was causing problem to that particular group. So I keep thinking, if I cluster this, would I leave this evidence? I mean, it's not in this paper because it was kind of out of the scope of this paper, but it's in our next paper, talking about how this productivity during in this arrangement of hybrid remote force scenario can also be harmful for professionals. But anyway, it's just a thought.
But that brings something that well, I saw in the session of the morning. It was in the morning for me, but from Lionel Brion, it was about doing things with industry, because we have large samples of open source software projects, but it's a bit difficult for researchers to get into, let's say, well, I wouldn't say real projects, but projects that have a client that with specific demands. And this is the case of what Ronnie did with companies. But what Tim was saying, like large samples. But how do we do that? How could we approach that in a large scale? See, if we are, it's not that easy for researchers to assign projects with companies for doing research and improving that. It's not everyone that has this industrial approach. So how do you see that? Because there's a lot of Ayusha's work was also based on open source software, right? Tim's work and many other works rely on students. So how do you see that? I don't know if in 5 minutes we can wrap that up.
I have a maybe Paul is going to talk about
Yeah,
that.
Paul's got 2 articles in this session, so he's got open.
Yeah, but I just want to say something before my supervisor, who is right there looking at me, say something. Is that we are in our study, we are talking about software teams, and to what point are we considering open source a team? I mean, if they are not under the same management or they do not have the same schedule or everything like that. So I think this is something that we need to also to reflect on it. But yeah, Paul.
I want to say something totally different. For Lionel thinks that software engineering research, that the primary purpose of software engineering research is to enable corporations. I dispute that. I don't think that the primary purpose of SE research should be to help corporations make more money. I think that our primary purpose should be to help the state of humanity. And helping the state of humanity means that you make way different choices about what you study and why you study it and what you look for. And sometimes it means that you study stuff that corporations aren't interested in, or worse, don't want studied because it'll make them look bad. You study stuff like, well, the well-being of people and how and technological ethics, and like how we can transfer power back from centralized groups that can control us, control the world, back to the population, right? So that they have more agency in their lives, and all of that. So like, you know, if something can make a lot of money, probably some company is going to be willing to spend money to create it. So let's not worry about that. Maybe we should worry about the things that don't make lots of money, but that we need for society to flourish.
There are interesting consortiums of. I wish Danae was here, but Ayusha. I remember Danae talking to me once about open source collaboration for social good, and long list, and you know this stuff, right? A long list of companies and people volunteering not to work on, you know, offering their spare cycles to social projects. Thanks. I don't think you're interested in that one. Okay, I'll try something else. Ronnie, you talked about clustering and ignoring people very briefly, and you rushed over it. Now, this bothers me. Like I want to say something that completely negates and kneecaps everything I just said. Notice I was arguing that we should use automatic methods to do large samples, find representatives and go for it. And even Ayusha was saying, let's look for representatives and work from there. Now, if I do work with minority groups, why should minority groups present themselves for interrogation, inspection, and data collection, given the terrible record society has about treating such minority groups? One thing that really bothers me with the idea of coming up with representative groups is there could be a small group that gets ignored by that. And we've seen examples where that's actually terribly important. Modern cancer therapies are typically not based on single drugs tested on vast trials. Typically, effective modern cancer therapies are personalized to individual. So on Tuesdays and Thursdays, I think we shouldn't even generalize. We should talk about methods for finding out particular lessons for particular local groups. And then on Monday, Wednesdays, and Fridays, I'm a software engineering professor, and I try to generalize. But Ronnie and Ayesha, how do we look across and not ignore the important small pockets?
Well, I think that's why we have case studies. I think in the name of generalizing everything, it makes no sense to miss out these small pockets. And which is why I was further even thinking about your idea of selecting representative using clustering or others. I think sometimes we can just go by our understanding as somebody who knows the field, or somebody who can understand what these minority groups look like, to just individually look at them and not always think about that we have to create one thing that works for all. And I think even creating a solution that would work for 10 people would be valuable, because once we have a solution, we might actually be promoting that sub-community to grow. And then that community could become from 10 to 20 and 20 to 100. So I think this is also another lens that we should be thinking, that by always talking about what works for majority, and I know it's easy to do something for majority because one, that's easily available. So I can just give a very logistic example from our work, that our objective was to try to reach out to men and women from all geographic regions. We said, okay, let's try to contact in a very balanced manner. We reached out to 50 developers from each region. What would you expect? That you will have at least similar survey response rate from different regions? No, it doesn't work this way. Perhaps the people who also happen to come from the majority regions have more liberty or leeways or privilege to answer to the survey responses, while others don't. So, I mean, okay, treating equally at this level is not going to help us understanding their problem. And that's, I think, one lesson that we are also taking away, that we will have to do something more to reach out to them. And so essentially, systematically, we are ignoring these subgroups or these sub-communities, which we should have, or which we really wanted to reach out otherwise. So what would it mean to reach them? I don't know, but it's a big problem and something that should be addressed.
At what point
we're reaching the end of the session, and there's still one open question. It's for Ayushi. I think well, maybe somehow there was an answer already for that, but it's from Diksha. She says, it is slightly alarming to know about the negative correlation between gender and geographical diversity. Would you have some ideas on how we could move forward from that, incorporate both gender and geographic diversity without hurting the other? I guess one hurting the other, right?
Yeah, that's a good question. Honestly, we were not expecting to see, or rather, we wouldn't have wanted to see such a relationship. I still would want to caution everybody here that it's a very weak relationship, and we don't want to overread into what we saw. But I think what it does open is a possibility that when we are trying to optimize on one dimension, there is a chance that we might be hurting diversity in some other form. And we have to be open to these ideas, because it's good to understand the big picture. And the reason I say this is because diversity is not just about gender or geography. it's about so many more things, so many more aspects that we are not even talking about. So it's good to understand that the efforts that we are making, what effects they have. Maybe this is the best solution we have now, but perhaps it can inform what future solutions may look like. And I think that's the best I can say for now.